Today we are going to read about our topic buses from chapter Computer Components. Let's begin. The CPU stands varies data value, instruction and information to all the devices and components inside the computer. If you look at the bottom of the motherboard, you will see a whole network of lines or electronic pathways that joins the different components together. This network of wire or electronic pathway is called the bus. As you can see in the picture, the red pointed area shows the bus route. Now let's talk about bus in more detail. A bus is a communication pathway connecting two or more devices. A key characteristic of a bus is that it is a shared transmission medium. Multiple devices connected to the bus and a signal transmitted by any device is available for reception by all the other devices attached to the bus. If two devices transmitted during the same time period, their signal will overlap and become garbled. Thus, only one device at a time can successfully transmit. Typically, a bus consists of multiple communicating pathways or lines. Each line is capable of transmitting signals representing binary 1 and binary 0. Several lines of a bus can be used to transmit binary digits simultaneously in parallel. For example, an 8-bit unit of data can be transmitted over 8 bus line. Computer systems can contain number of different buses that provide pathways between components at various levels of the computer system hierarchy. Now let's talk about what are system bus. Firstly, a bus that connects major components of computer, processor, memory is called a system bus. A system bus consists typically of about 50 to hundreds of separate lines. Each line is assigned to a particular meaning or function. System bus is usually separated into three different functional groups that are: Number 1, we have data bus. Second, address bus. Third one is control bus. In addition, there may be power distribution lines that supply power to the attached modules. Now look at the picture over here to get the more clear idea in your mind that how the system bus module looks like. So first we have data bus. Data bus is a collection of wire through which data is transmitted from one part of a computer to another. Data bus can be thought of as a highway on which data travels within a computer. This bus connects all the computer components to the CPU and the main memory. The number of lines being referred to as the width of the data bus because each line can carry only one bit at a time. The number of the lines determine how many bits can be transferred at a time. It is a bidirectional bus. The size, width of the bus determine how much data can be transmitted at one time. For example, a 16-bit bus can transmit 16 bits, means 2 bytes of data at a time. 32-bit bus can transmit 32 bits, means 4 bytes at a time. The size, width of the bus is a critical paramount in determining the system performance. The wider the data bus, the better, but they are very expensive. Now second, we have address bus. Address bus is a collection of wire used to identify a particular location in the main memory. It's called address bus. Or in other words, the information used to describe the memory location travels along the address bus. Clearly, the width of the address bus determines the maximum possible memory capacity of the system. An address line directly addresses to an memory locations. It is an unidirectional bus. The CPU sends address to a particular memory location and I/O paths. The address bus consists of 16, 20, 24 or more parallel signal lines. Number 8086. Address 20 address line could address 1 MB of memory. The second one is Pentium. 32 address line could address 4 GB of memory. Italium means 64 address lines could address 264 bytes of memory. The third and the last one is control bus. Because the data and address line are shareable by all components, there must be a mean of controlling